Welcome everybody to the next training module in the Safety Committee University. We're really excited today to have with us David Hanson. David is a senior safety management consultant at SAIF Corporation, providing high-level service to Oregon businesses. He has an expertise building dynamic safety teams and developing high-performing safety cultures. He spent over 18 years at Timber Products Company as a supervisor and a safety coordinator and facilitated continued certification into OR-OSHA's Voluntary Protection Program. David has a background in industrial safety. He's a safety in motion trainer, and he's organized efforts to improve ergonomics in the workplace. David was recognized for his outstanding efforts in safety and health at the Oregon Governor's Occupational Safety and Health Conference. David is here today to share with us an extremely important training module in the Safety Committee University, and that is effective incident analysis. He's one of the experts, in my opinion, on this subject. I worked with him closely at Timber Products, and he was the best we had at conducting effective incident analysis. So without further ado, please join me in welcoming David Hanson.
Thanks, Mike, for that introduction. So how your organization analyzes incidents really demonstrates what your organization values and how your team addresses challenges in the workplace. So we're going to discuss those methods today on how to conduct excellent incident analysis and proven approaches to prevent injuries in the workplace. This training is required for safety committee members in Oregon. However, many of the techniques we're going to discuss can help the organization address many other challenges in the workplace. Let's get started. So these are our objectives today. First, we're going to review why we analyze incidents and accidents. And we're also going to talk about the safety committee responsibilities and the responsibilities that safety committees have. I'm going to show you a practical approach to incident and accident analysis. And I'm going to also kind of coach you on how to find system causes to incidents. And we're going to get a chance to kind of use some of the skills that we talk about to analyze a couple incidents. Also, we're going to talk about how to identify root causes and accidents and injuries, and then how to use the incident analysis process to achieve the best results. So the big question is, why do we need to conduct an incident analysis? Obviously, this is probably the most important reason right here, is to prevent employees and coworkers from suffering injuries. That's the biggest reason right there. There's no reason bigger than that. But also, we want to do an incident analysis to dig down to root and system causes of incidents. And by doing that, we can determine corrective actions so that we can actually prevent employees from suffering injuries. And then we can evaluate and implement best practices. And as you do incident analysis, you're going to be able to discover some trends in your workplace in how accidents happen or how they almost happen. And you can use this information to make corrective actions to prevent injuries to employees and coworkers. The bottom line, and this isn't the most important reason for doing an incident analysis, but it is a reason. It's required by Oregon-OSHA. And so this is the rule that Oregon-OSHA has for all workplaces. This is for the employer. Each employer must investigate or cause to be investigated every lost time injury that workers suffer in connection with their employment. To determine the means that should be taken to prevent recurrence, the employer must promptly install any safeguard or take any corrective measure indicated or found advisable. Okay. Now, these are the Oregon-OSHA requirements for the safety committee. And so the safety committee has specific requirements. And this is one of the big reasons in the state of Oregon that safety committees are required to have this training. Safety committees must work with management to establish, amend, or adopt accident investigation procedures that will identify and correct hazards. And safety committees need to evaluate all accident and incident investigations and make recommendations for ways to prevent similar events from occurring. So what kinds of things are we talking about analyzing here? The first one that we want to pay close attention to is when someone gets hurt, personal injury. We want to analyze that. We want to prevent that. That's a big one. Another one is property damage. When something gets damaged, it's a significant cost to our company. And we want to make sure that we're preventing these property damage and significant costs to our company to make our workplace safer. Near misses are another one, and you'll hear me challenging you to investigate and use some of these tools on near misses quite often. This is a picture you can't really see, but there's a vehicle that drove off the road, and you can see where that one is down near the culvert there. And that is almost where he went as he drove off the road. So near miss, yeah, that could have been a really bad day. Other near misses that we should consider. Another thing that we want to watch for is unsafe behaviors. We may be in a position where we can actually identify unsafe behaviors and use some of these techniques we're going to talk about today to target and reduce those unsafe behaviors. Maybe some unsafe work practices. In this case, we're carrying more than we really need to. Could cause, a strain or slip, trip, fall. What about unsafe conditions? Unsafe conditions are another really good one, but look at that picture. There's a drivetrain there and it's exposed. We've got pinch points, we've got nip points. It's definitely an unsafe condition. But what was probably happening here was that the guarding was not placed back on. There was some servicing going on, problem was solved, and the guarding wasn't replaced appropriately. So yes, it's an unsafe condition. It's also an unsafe work practice. This is another unsafe condition, but if you look at that, this is actually a fuse box, but there are no fuses here. Somebody is using a bypass here. And so while it is an unsafe condition, it's also an unsafe work practice. The fuse is there to protect property in case of an overload, and we've bypassed that safety feature. So you heard me talk about why we need to investigate near misses. And a lot of times, the problems that we are encountering in our near misses are the same kinds of problems that we encounter in our injuries. And this example that I'm going to show you shows why this is the case. So in this example, an employee trips in a pothole. There's a pothole in the driveway in the parking lot. And the possible outcomes, the first person that trips in the pothole catches himself, avoids the injury, goes on with his day, doesn't think about it again, no problem. Next person comes along, stumbles, and ends up with a sore ankle, okay? They go home, ankle sore, next morning it's a little swollen, a little sore to step on. Then after a while it gets better and the swelling goes away. No medical, no lost time, not a big problem. Third person comes along, same pothole, same hazard, falls down, fractures his ankle. Okay, nothing else has changed in this situation except the outcome. And this is why we talk about, I'm challenging you to investigate some of these accidents, incidents should be analyzed for the near misses. Near misses are great opportunities. For every recordable injury that we see, there's 7 to 9 near misses, okay? And so this is actually a nice diagram that kind of shows what I'm getting at. It shows why this is important. Time spent studying near misses and unsafe behaviors has a larger pool of data. So if you look at this triangle here, you see we have a certain number of unsafe behaviors at the bottom, and these unsafe behaviors contribute to a certain number of near misses. And these certain number of near misses ultimately contribute to minor injury first aid events. And those near misses also contribute to serious injuries. Well, if we only study the serious injuries, we're missing out on a lot of other data here. We actually have a lot more information available to us in this pyramid. These two at the top of the pyramid are called trailing indicators. These are the things that we look at after they've already happened, It's like looking through the rear view mirror of your windshield of your vehicle, looking in the rear view mirror, measuring what's already happened. The near misses and the unsafe behaviors, these are leading indicators. Leading indicators are things that are happening that actually predict those trailing indicators down the road. This is why I challenge organizations to look for near misses that they can investigate, because you can learn lessons from those near misses. They're absolutely free. No one had to get hurt to learn those. And you could be preventing your next serious injury. And then all of these happen as part of the system. We're going to talk about the system of how work gets done at your organization. And the system, the things that are happening in the system either develop or prevent unsafe behaviors. They develop or prevent near misses. And so we're going to talk about how to analyze those here in a little bit. But first, I want to talk a little bit about underlying beliefs on how you do incident investigations. When you're analyzing an incident investigation, there's certain things that you should have an understanding about. 98% or more of the accidents that we see are system failures that can be understood from a system standpoint. Another thing that we want to talk about is that all accidents are preventable. A thorough analysis will determine the causes and contributing factors and will prevent future injuries. So if we understand that all accidents at some level are preventable, then when we analyze an incident, it's easier to find things that can prevent that. Sometimes I'll ask a group of people, I'll ask them, are all accidents preventable? And some people will say yes, and some people will say no, and that's okay. But what I'll ask after that is I will ask, do all accidents have preventable elements? And nearly everyone will raise their hand to that one. And that's really what we're looking for. That's what we mean when we say, are all accidents preventable? There are elements to the accidents that could have been prevented. And then ultimately, what's our goal? Our goal is no accidents. No accidents are acceptable. Our ultimate goal is zero harm to people. We want everyone to go home as healthy as they came in the morning, at the beginning of their shift or during the day. So let's talk about the process for incident analysis. First, you want to preserve the scene. You want to gather any relevant facts. You're going to do a systems analysis and look for countermeasures and best practices. And then you're going to do a follow-up and follow through. So we came up with all these things that we're going to do to prevent this injury from happening again, prevent this incident from happening again, and then we're going to follow up. And we're going to make sure that we continue to follow up until we've completed all the things we needed to do to prevent that incident from happening again. So that's your continuous improvement process. And so with the class today, I've provided a couple of incident analysis tools for you to use. You can use these, or you can use ideas from these to create your own incident analysis workbook. But these are great tools that are available to you to analyze incidents and accidents and create a system for identifying problems, things that you want to change, countermeasures, solutions, and then following through. These are both great tools. And so when you put together a team, you may be putting together a team to help you do some of these incident analysis projects. Think about the kinds of folks that you want on that team. For example, an employee from the work area, someone who does work in that area all the time, maybe even someone that does the tasks that were being done that may have caused the incident that occurred. Also, maybe a supervisor from a different work area. Sometimes it's kind of nice to have some outside eyes available. Another good one is to have a maintenance supervisor, someone who's in charge of maintenance and making changes to workspaces. Because as you're coming up with solutions, having a person from the maintenance department there is going to be a really great opportunity, because they may have some insight into what's possible, or maybe some things that have been tried before. That could be some good information. And then when you do decide on what to do, they can actually be an advocate on how to get that done. Another thing would be a safety person, someone who has some responsibility for safety in the facility. And then a safety committee member is always great, because safety committee members have training. And then when they go to the safety committee meeting should be reviewing accidents and incidents that happen at the site, so they can talk about, what's being looked at in relation to a certain incident or an accident. Safety committees members are a great group of people to have on an incident analysis team, in my experience. So next, you're going to collect the facts. Focus on finding the facts about the event. Remember to gather valid information without drawing conclusions or assigning blame. You want to create a sequence of events to show chronological relationships. That's really good because it shows you how over time all the things that happened are interrelated and how decisions were made and events occurred in a sequence. So you may have multiple timelines and they may intersect at certain points. Also, you want to document any observations. If it's right after the incident, you may be able to take photos. There may be some video surveillance if it's available. Interviewing employees and witnesses is a great way to get information about what happened. You can talk with the parties involved, obtain initial statement about the description of the accident. Remember to ask open-ended questions. And then open-ended questions are great because then people have, it's not just a yes, no answer. They're able to expound on their answers and give you more information. Also, you may want to review relevant records, maintenance, training, job hazard analysis, training, policies and procedures. These are all things that are going to be really important for you to go back and take a look at. Were we following the procedures? Maybe there's something wrong with the policy. Those are all things that you're going to look at. And then timelines. Again, timelines are great because it really shows how the event came to occur and how it ended up happening. Then we're going to take a look at identify system causes. So every accident incident is caused by a set of contributing factors. Okay, so these factors represent the surface or the system causes that led to the event. And your goal is to identify these by analyzing how and why each consecutive event happened. Now remember, surface causes are a little different than system root causes. So surface causes are unsafe behaviors and hazardous conditions that causes the effect and the outcome, but it is not a root cause. And then the system root causes are underlying problems that cause the incident. So those underlying root causes actually allowed those surface causes to be in existence. Okay. And so you're going to understand, you're going to try to, as you're doing this investigation, you're going to be trying to understand and identifying how these causes are interrelated. And there's a couple approaches. If this sounds like a lot and it sounds really involved, I'm going to give you some tools to simplify, make this approach simplified so you can take bite-sized steps to go through this process. And the first one is, after you've identified those surface causes, then you get to the underlying root causes by following what we call a 5 why approach. So everything that happens in your organization is part of a system. All the good things that happen because of how everything works within the system at your organization. And your organization has 4 different parts, main parts. One of them is management systems. Management decides what work gets done, how it gets done, what resources get allocated to what work, okay? How the environment is laid out. That's all management's role in deciding how that happens. Now the employee oftentimes is the people doing the work. They're the front line getting it done day in, day out. Equipment is the tools that we use to get the work done. An environment. What is the environment? Maybe it's wet, maybe it's too sunny, maybe it's dry, maybe there's a slippery surfaces. These are all environmental considerations. All of these systems throughout the day work to do all the things that your organization does successfully. Now, sometimes all of these systems work together to create problems. And this is a tool that I'm going to make available for you to identify all of the elements of the system, potential system problems. So first thing that you can do is think of each one of these bullet points as a lens that you're going to put and you're going to look at the incident after you've collected all your information. You're going to look at the incident through each one of these lenses. Management, policy enforcement. What kind of policy enforcement was there? Was there a policy? You can ask a lot of questions about the policies and get a lot of good information. Maybe we don't have a policy. Maybe we need a policy. What about hazard recognition? Did we even know this was a hazard? Accountability. Are we holding people accountable for following the policies? Okay. So each one of these is a bite-sized lens that you can use and look at the incident through each one of these lenses at a time. That way you're not trying to look at it all together all at once. Okay. Supervisor training, corrective action, production priority, proper resources, job task, orientation, hiring practices. Employee systems. Maybe the employee wasn't following procedures. Maybe they weren't trained. Maybe there's some pre-existing conditions. Maybe they're not using the equipment properly. Equipment systems, tool suitability. Maybe we're using the wrong tool. Maybe the tool that we're using isn't adequate. Maybe it isn't being maintained. Maybe the tool that we're using isn't guarded, or we're not following the manufacturer's recommendations for the tool. Environment. What kind of layout? What is around the area where this incident happened? Are there chemicals? Is there high temperatures, low temperatures? Is there noise? Radiation, weather condition, vibration, ergonomic issues. Okay, so environmental considerations. And so each one of these bullet points is an opportunity to ask very specific questions about what happened in the incident and come out with some really good information. And one of the things you'll notice as you analyze these systems is you'll start to see a lot of overlap, and you'll see how these systems are interrelated, and you'll get some really good information because you will find overlap, and you'll find something in almost each quadrant. The next thing that I was going to talk about is when you don't ask why, you miss out on opportunities to learn. And so as you're interviewing people to try to get this information from them, remember, it's not an interrogation, of course. And, it's kind of an interesting thing that happens when people realize that they're being listened to. When coworkers understand that your main motivation is not to find blame, but to make changes to the system that caused the incident, you'll get better information. And better information about possible causes and solutions. So this is a good exercise for your incident analysis team. So once you've identified some of those surface causes and some of those system causes in the management, employee, environment, equipment surface causes, we can actually go through and ask why to each one of those questions. And so why did the employee get injured? Well, the employee slipped on water. Well, why did the employee get slip on the water? Why did the employee slip? There was water. Well, why was the water there? Well, the water fountain preventative maintenance wasn't done. Well, why wasn't the water fountain preventative maintenance done? Well, maintenance staffing is low. So you've got this direction that you're going. You're asking why to each question, and then you ask why 5 times, and you're getting closer to root causes now. The only problem with this approach is that it's very linear. It goes kind of in one direction. And what I would challenge you to do, if you're going to use the 5 why approach, don't let yourself only have one answer to a why. Okay. So you end up getting something more like a fishbone. So you end up getting kind of a tree of information about the incident. And we'll actually try to use this a little bit later on an incident. And this is kind of a helpful picture. You don't have to get too involved in reading the parts, but think about surface causes on a accident weed. Think about the surface causes as being the leaves, and then the root causes are the roots. So without those roots, the leaves can't happen. Okay, and so as we're asking why, we're driving down into the soil trying to find those root causes. We want to solve the surface causes, but we're going to get more results if we solve the root causes. Remember, every incident, injury, has multiple contributing factors and root causes. There's never just one root cause. And then also another thing is, remember that human behavior always occurs within a larger system. If you in your analysis you find out the employee made a mistake, don't stop. Keep going, dig a little deeper, find out why they made that mistake. Avoid jumping to conclusions and climbing the ladder of inference. So one of the things what that means is, don't make up your mind don't make up your mind too soon. Once you make up your mind, it's hard to get back down that ladder of inference and come up with new conclusions. And so just study the facts at first and find out what happened and why it happened. And then your conclusions will come out when you start identifying corrective actions. Another thing that's kind of a neat trick, but it only works if you have trust involved with the relationship with the injured worker. But how can we prevent this from ever happening again? This is a good approach to get some really good information. It will be limited. It's not the only information that there is to find out about the incident, but it's good information because they know if they do that job very much at all, they know what they're going to do differently next time to prevent that from happening. So these are common deficits in accident investigation, incident investigation analysis. Not giving enough time or importance to the process. So if you try to get it done too soon, you're not going to get all of the information that is available. So you want to make sure that you're doing a good job, giving it enough time. By giving enough time, you're placing more importance on getting a really good analysis and coming up with some really good solutions. Another thing is, when you do your incident analysis, you should be involving the right people. Who are the people that know what kinds of solutions have been tried in the past? Who are the people that know how to do that job the best? Who are the people that maybe have had other near misses or have had some experience in those areas? Who are the people that have an ability to have some outside eyes and ask some good questions about the operation? So make sure we're involving the right people. Also, avoid making assumptions or jumping ahead to conclusions. We kind of talked about that already. And then when you start when you start putting together your analysis and you start coming up with corrective actions, make sure that you're following up. Because if you come up with a great incident analysis, you come up with all these system causes and root causes. If you're not following up, you're not making any changes. You're not doing the ultimate purpose of an incident analysis, and that is to make things better. And also, you want to make sure that you're documenting, communicating all your findings, your actions, and your results. So this is actually a real incident analysis that I saw once. And once you've identified causal factors to an incident, make sure that there aren't other causal factors. In this specific incident, employee was in a hurry, not paying attention. That was a surface cause. It's a real surface cause. The root cause was identified as a work environment hazard, and there was an unsafe work practice that was being used. And then the corrective action was that the employee was counseled to pay attention to their surroundings. So obviously this is an incomplete incident analysis. When I see this incident analysis, I have all these questions. Like, one is, why were they in a hurry? What were they paying attention to? What is the work environment hazard? And what was the unsafe work practice? And what maybe we can make some changes to those four things, and maybe we can maybe those could be our corrective action. But as you see here, what we've done is we've placed all of the corrective action in one of those quadrants. Remember our four system quadrants: management, employee, equipment, environment. Remember those four? Well, our corrective action only addresses one of those, right? We're only fixing the employee portion. There's so much more here that we can dig into. There's clearly an environment issue, and there's definitely a management issue as well. So there may be some other improvements that we can look at to try to prevent this from happening again. Another thing that we should understand is that common sense is not common. The employee is seldom, is seldom just being stupid. We can improve safety controls. So we can improve training, we can improve safeguards, we can improve procedures, we can improve job hazard analysis. So if you have an analysis for that task, we can improve that. We can improve supervision. So there's all kinds of things that we can do to give the employee more tools to do the job safely. And common sense is a product of our experience. And so what is common sense for one person may not be common sense for another. So we should never take it for granted that someone knows something in particular, because they may not have had experience with that type of work before. So make sure that we're going over those things that might be common sense for some people, but not for everyone. Another thing we need to remember is that we can blame. If we blame and punish, we're going to lose our opportunity to learn and improve. And so once we start blaming people for problems, we actually stop learning. And so we want to make sure that when you do your incident analysis, it's clear to everyone that your goal is not to blame or punish. Your goal is to actually learn and improve. And then when you start making improvements, the improvements aren't just, you're not just trying to fix the worker, but you're trying to fix all of the systems involved with that accident that happened, okay? So I'm gonna show this video. I want you to take some time, watch the video, and identify as many surface causes as you can. If you think of some potential root causes, go ahead and write those down too. So just start identifying some causes, and then when we're done, we'll go through and we'll call some of those causes out. And feel free to pause the video and rewatch as needed. Take as much time as you need.
The Little General gas station and convenience store was located on Flat Top Road in Gent. Inside the wood-framed building, the store sold soft drinks, magazines, and snacks, as well as pizza, which was cooked in 2 propane-fired ovens. In 1994, the Southern Sun Company installed a 500-gallon propane tank against the back wall of the store. Southern Sun sold its propane business to Ferrellgas in 1996. The logo on the tank was changed, but the tank itself was left in place. Years later, in January 2007, the Little General Company changed propane providers from Ferrellgas to Thompson Gas. Appalachian Heating, a local firm selling propane for Thompson Gas, installed a new tank 10 feet from the building. There were still about 350 gallons of propane in the old tank, which Appalachian Heating intended to transfer through a special valve, hose, and pump to the newly installed Thompson gas tank. To make such a transfer, a technician must first unscrew a safety plug from the top of the liquid withdrawal valve on the tank to be emptied. The safety plug has a small hole in its side called a telltale. If propane is released through the hole, it is a warning that a dangerous release is likely if the plug is completely removed. So if propane is seen, the plug should be retightened. If no propane is observed escaping, the plug may be removed, and a valve with a special fitting is then threaded into the liquid withdrawal valve. This special fitting depresses a spring-loaded mechanism, allowing propane to flow through the valve and into the hose to transfer the propane. The CSB determined that on the day of the accident, several factors combined to turn what should have been a routine tank exchange into a tragedy. On the morning of January 30th, 2007, 2 technicians from Appalachian Heating arrived to put the new tank into service. The lead technician then departed for another job site, leaving an inexperienced junior technician to prepare for the transfer of propane unsupervised. At about 10:25 a.m., the junior technician began to unscrew the safety plug from the liquid withdrawal valve, a valve the CSB would later determine was permanently stuck in the open position. Propane likely flowed out of the hole in the plug, but the technician had not been trained on the importance of checking for the escaping gas. Immediately, as the technician removed the plug, a jet of propane sprayed upward through the valve. A billowing white cloud of flammable propane vapor formed behind the store. The propane struck the eaves of the building and flowed into the store through vents in the roof overhang and directly into the restrooms through 2 vent pipes. The flammable gas also diffused down through the ceiling. The gas, colored gray here for illustration, was invisible to the employees inside, but they noted the spreading odor associated with propane. The dense vapor also accumulated at ground level around the tank and the foundation of the building. The technician, standing in the midst of the propane cloud, was unable to stop the release due to the force of the jet. Over the next almost half hour, all 4 store employees remained inside, and the technicians stayed by the tank as others responding to the propane release arrived. There was no evacuation as propane continued to escape from the tank. At 10:28 a.m., shortly after the leak began, the junior technician called the lead technician, informing him of the situation. At 10:31, the lead technician called Thompson Gas Technical Support for guidance. The lead technician then called the junior technician back and likely told him to call 911. At 10:40 a.m., the junior technician made a 911 emergency call.
911, where's your emergency?
He told the operator, "I need the fire department down at the little general store in Gent. I've got a propane leak. I need their help to secure the area." He went on to say, "I work for Appalachian Heating. We've had a dysfunction in the tanks and I have a leaky tank." At 10:43 a.m., the county 911 operator broadcast the report of a propane leak.
Raleigh Control, Station 110, Station 110, injuries on Flattop Road in Gent, the Little General, across from Flattop Lake. Report of a propane leak.
4 minutes later, at about 10:47 a.m., a Gent Volunteer Fire Department captain arrived. He ordered the store to close. The employees turned off the gasoline pumps, locked the door, and remained inside. They posted a sign on the door reading, "Store closed due to gas leak." Despite the imminent danger, no one inside or outside the building evacuated. Next, 2 emergency medical technicians arrived in an ambulance. They went to the tank to examine the technician for a frostbite injury, likely caused by contact with the liquid propane. Just after 10:50 a.m., the lead technician returned to the scene and joined the junior technician at the leaking tank. A short time later, another volunteer firefighter arrived in his personal vehicle and met the others at the tank. It was now approaching 10:53 a.m. The 2 propane technicians remained near the leaking tank. The fire captain, the firefighter, and an emergency medical technician stood nearby. The other EMT directed traffic away from the store. The 4 employees waited inside. The captain told the firefighter, "Make sure everybody's out, okay?" But 30 seconds later, as the firefighter walked toward the store, the propane found an undetermined ignition source and exploded.
911, where's your emergency? The propane tank blew up. The building is gone. It's gone, lady.
The explosion leveled the little general store, propelling building fragments in all directions. The propane tanks landed more than 50 feet away.
I remember the store sitting there, and when I arrived, there was nothing sitting there. And that's about the best way to describe it that I know of.
The two technicians, the fire captain and the EMT standing near the leaking tank, were struck by flying debris and killed. The 4 store employees and the other firefighters survived, but they sustained serious burns and other injuries. The EMT who had been directing traffic survived with an arm injury.
The liquid withdrawal valve on a propane tank is very rarely used. It is designed to enable propane companies to actually empty the tank of its contents.
The CSB performed extensive testing and examination of the liquid withdrawal valve from the tank in Gent. CSB investigators concluded that a manufacturing defect 2 decades earlier likely caused the valve to jam permanently in the open position. Only the safety plug had been preventing liquid propane from escaping. Jeff Wanko led the CSB investigation.
This is the actual valve from the incident at Gent. The CSB was able to section the valve so we can take a look at the interior mechanism and workings of this valve. We found that the hole drilled through this lower guide was too small for the stem to move freely.
With the valve stuck in the open position, propane was likely released through the telltale hole when the unsupervised junior technician, who had received no formal training, began removing the safety plug.
We found that the propane technician working on the tank was not trained in the standard procedures for the job tasks that he was doing, and that he likely removed the plug without checking the hole for a propane leak.
The junior technician who was servicing the tank that morning had no training. He had only been on the job for a month and a half.
The propane industry's primary training tool is the Certified Employee Training Program, or CETP. It was developed by the Propane Education and Research Council, which was established by Congress in 1996. The training cautions technicians to unscrew the safety plug part way and then check the telltale hole for escaping propane for at least 30 seconds. The training emphasizes, if in doubt, do not remove the closing cap. But the junior technician had never received any formal industry training. In fact, only 14 states in the country have any training or testing requirements for propane technicians. 36 states do not have any requirements.
The state of West Virginia currently does not require that propane technicians be trained in how to perform their tasks or how to perform their tasks safely.
The CSB recommended that the governor and legislature of West Virginia require training and qualification for all propane technicians. And the CSB recommended that the National Fire Protection Association amend the National Fire Codes to require specific training and testing for all personnel who handle propane. Federal OSHA regulations require that propane technicians who perform installation, removal, operation, and maintenance work shall be properly trained in such function. However, the rules do not define what constitutes proper training. The CSB called upon the National Propane Gas Association to request that OSHA determine whether the industry's Certified Employee Training Program meets OSHA requirements.
We found that the propane industry standard training program covers all of the routine tasks that you would expect a propane technician to perform. However, this training did not cover any emergency tasks and did not cover what a propane technician should do in the case of an emergency.
On the day of the accident, neither of the propane technicians evacuated the area of the cloud, nor did they instruct others to do so.
The first priority in responding to a propane emergency is to get people out of harm's way, to evacuate the area and make sure people are safe and not in an area where they could be injured by a fire or explosion.
The CSB noted that propane technicians are frequently called upon to assist firefighters in responding to propane emergencies.
The propane technicians are a very valuable part, a very big asset to us in this situation. We would like to know through the fire service that these technicians are trained to the level that they can tell us point blank, it can't be fixed. We have to get away.
The CSB recommended that the Propane Education and Research Council revise the industry training program to include emergency response guidance for propane technicians. The training should emphasize the need to evacuate the scene of a release until the hazards are fully understood. And the Council should develop safe procedures for transferring propane between tanks or prohibit such transfers.
I would like to know that the technicians, when they're responding with my firefighters out there, that they're educated to the highest level they can be.
Had the tank been installed the required 10 feet away from the building, there still may have been a large fire from this incident. However, it's unlikely that the propane would have accumulated inside the building to an explosive level.
The tank was located directly under the roof vents, providing a direct path for the propane gas to enter the building. OSHA regulations and the West Virginia State Fire Code both require that 500-gallon propane tanks be located at least 10 feet away from buildings. But for more than a decade, Ferrellgas personnel had allowed the propane tank to remain directly against the back wall of the little general store, even as they refilled the tank more than 100 times since it was initially installed.
The investigation team interviewed many delivery and service personnel who worked on this tank. All of them were well aware of the 10-foot separation requirement, and all of them were aware that this tank was in violation of that separation requirement. But none of them had reported the unsafe placement of this tank to their managers.
Drivers told CSB investigators they believed the tank location had been approved, possibly under a variance from current rules. But there was no variance. Although Ferrellgas had twice inspected the propane system at the Little General Store in 2000, the tank was never relocated. The CSB recommended that Ferrellgas establish an improved auditing system and an inspection program for propane systems based on the requirements of the National Fire Code for propane.
Okay, so you all had a chance to watch the incident, the analysis from the CSB. So think about, and I had you write down some surface causes, root cause. If you wrote down a root cause, that's great too. These were some that I came up with, just a handful. There's probably more, but you know, first thing, surface cause, we got employees. We got lots of employees in unsafe areas. I've got employees that work for the gas company. I got employees that work for the convenience store. And then I end up having emergency service employees. So I have all these employees that are clearly in an unsafe area. Definitely a surface cause. And that probably falls mostly in our environment category. Remember our system, our 4 system elements: management, employee, equipment, environment. Well, that's mostly environment, or I guess it could be employee as well. So propane tank was way too close to the building. In fact, there's actually an OSHA rule that said that it had to be further away, and they were working on that, but that initial event where that propane tank was placed so close to the building is one of the surface causes that caused a lot of problems on this day, and that's environment and equipment. It could be employee if we trace it back for training. If someone who installed that tank didn't have the training, could be employee. Management maybe didn't do the training too. So you can kind of see a relationship there starting to form. Another one was we had the propane was able to get into the building to be ignited. And some of that was because of the location of the propane tank, right? But we definitely have an environment and an equipment failure there. The manufacturer's defect in the telltale valve, that was an equipment failure. That started way back at the manufacturing plant whenever that telltale valve was manufactured. But that was clearly a problem that could have been identified at some point. Next one that I noticed was a junior technician wasn't prepared to be left alone for the task. You know, that would be an employee system, or the supervisor shouldn't have left him in that situation. He was not prepared for that. He didn't have the training or the knowledge that he needed in order to handle that event. And then Hazards were not properly evaluated or recognized in order to implement adequate procedures. And this was from all organizations involved here, right? Employees, management, lots of hazard recognition breakdowns here, okay? So some good surface causes there. And you probably had some that were on this list or could be close to the ones on this list, or maybe you had some other ones entirely different. So now we're going to ask some why analysis. And so one of the things I'd encourage you to do is when you ask why, never give yourself one answer to the why. Because if you just give yourself one answer to a why question, you start kind of getting yourself into a corner. So a lot of times there's more than one answer to a why question. So at the top here, we had an explosion disaster. And obviously this chart I made is incomplete, but it kind of shows you the way to investigate this sort of incident. Explosion disaster. Why did it happen? Well, we had employees in an unsafe area. Well, why did we have employees in the unsafe area? Well, we had uncontrolled hazards that weren't recognized. We also had a junior technician not prepared for the task and was left alone by the experienced technician. Okay, why was the uncontrolled hazard not recognized? Well, we had emergency procedures were not established and emergency procedures were not followed. Over here on the right-hand side, the propane ignited inside the store. Why was that? Propane leak into the store. Why was that? Well, the propane leaked into the store because of a manufacturer's defect. Yes. Tank was too close to the store. Yes. Junior technician was not prepared for the task and was left alone by the experienced technician. You can see that there's a lot of overlap that we're seeing as we do our analysis. You're going to see how all of these kind of relate to one another. And I'm trying not to give myself just one answer to each one of these questions, but I'm kind of running out of space here. But this kind of shows you how to keep asking why, make sure we're getting multiple answers to each why question. You know, one of the things that down at the bottom, I'm starting to get closer and closer to my root cause, right? Training procedures were not established. Training procedures may not have been effective. Established safety rules may not have been followed. Or maybe the established safety rules weren't effective. So lots of things, lots of directions that we're going to go as we do this, as we try to find our root causes here. And so think of another way to think of system root causes is you think of an iceberg. You know, an iceberg, most of an iceberg is underwater where you can't see it. You only see a small portion of the iceberg above water. So remember, there's a lot of these underlying root causes that we're trying to get to as we ask why. So let's talk about some of them that we see. Established procedures weren't followed, okay? These were established either by the companies involved or the government agencies involved like OSHA. Also, established procedures were ineffective or inadequate. And so do we have established procedures to make sure that people get away from that hazard? We have a flammable propane that's going into the area and creating a potential fire hazard. Should we be getting people away from that area? That probably would be the first thing that I would be looking at. So what are the procedures from the standpoint of the technicians involved? Are they trained to get people away from that area? Are the firefighters involved? Are they trained to get people away from that area? If there were training, if training was done, it was either ineffective or inadequate, or it hadn't been done yet, or the training procedures weren't followed. And a lot of these that we're identifying now as we get down to the root causes really fall pretty solidly in the management category, because it's management's responsibility to make sure that established procedures are followed, make sure that emergency procedures are followed, make sure that they're effective, make sure that they're established. Training procedures are followed. Supervision accountability systems were not adequate to make sure that procedures were followed by frontline employees or updated as needed. Okay, so maybe you had some of these already as you're asking questions about why things were happening as you're watching the video. but a lot of system root causes that you can dig into that revolve around how work gets done, and how this tragic incident happened. So once we've identified our system causes and surface causes, you're ready to identify possible solutions. And so these solutions need to be prioritized based on their level of effectiveness. And you must always remember to list multiple solutions when possible. When I'm trying to prevent an incident from happening, if I only do one thing, it's a lot more difficult to, it's a lot easier for that one thing to revert back to the way it was. And so I like having multiple layers. So if I've addressed something in each of those 4 columns, the management, employee, equipment, and environment, then in order for that accident to happen, then all of those things would have to recombine all at the same time. It makes it much, much less likely that it's going to happen if you change multiple things. So let's talk a little bit about the kinds of solutions that we're looking for. What you don't want to do, don't do what I did years and years ago, where once I'd find a new hazard, I would try to find personal protective equipment to deal with that hazard. That was my first, and that isn't a problem, except I should have started with the question, can I eliminate the hazard? But I didn't start there. I started with what kind of personal protective equipment can I use to protect from this hazard? But if you start from eliminating the hazard, what you can do is you can, you don't have to worry about that hazard ever again. Once in a while, you can eliminate a hazard. If you take away the hazard, then nobody gets hurt, okay? And that hazard doesn't have an opportunity to hurt someone. Another thing we can do is we can substitute the hazard. So maybe we're using a chemical that is a little more dangerous than we need, and there's another chemical that'll do the same job, but maybe it's less flammable, maybe it isn't as caustic, maybe we don't need as much. We could substitute one hazard for the next. Another thing we can do is include engineering control. Engineering controls, probably the most common one that we think about is basically putting up a barrier, a guard, keeping people out of that area in case something goes wrong. If someone trips, they don't fall into the hazard, okay? Or if they turn around too quickly, they don't bump their head on a certain part of the machinery or something. So we have a guard in place that protects people in case of unforeseen but potentially expected things that could happen. We can keep people and things out of that area that could be dangerous. So you're basically putting up a separation between you and the hazard. Another thing we can do is administrative controls, or management controls is another way to indicate it. Administrative and management controls kind of change the way that work is done. So maybe instead of doing it this way, where someone might have to lift it up and use bad posture, we put together a policy that when you do this, you use this tool over here that we've assigned to lift this so that you're not having to use bad posture that could hurt your back or something like that. Or maybe we put up signs that tell people that they need to wear safety glasses, or anytime you're putting up a sign, it's an administrative control. And really, anytime you put up a sign, it should be coupled with some training that occurs. So administrative controls could also be training, policies, procedures that are put in place that decide how work is going to get done in order to protect people from hazards. Personal protective equipment. There's always a place for personal protective equipment, but really what you're doing is you're controlling your exposure to the hazard. So you're not eliminating the hazard. You're not separating somebody from the hazard. You're putting up a barrier on the person to minimize the exposure to the hazard. There's a lot of need for personal protective equipment and good personal protective equipment, but it's a lot more work managing a personal protective equipment system. You got to make sure that you have the personal protective equipment, make sure you got the right stuff, make sure that people have the training they need, make sure that it's getting replaced properly, people know how to use it. There's a lot of work involved with managing a personal protective equipment program. And so it really comes down to this is an equation that I like this because it shows that you can have a hazard, and as long as the hazard is never exposed to anyone, you're not going to have an injury. And that's kind of the fundamental principle behind those controls. You know, engineering, we put up a guard. The guard keeps someone out of the hazard, and so there's never an exposure. And so everything that, you know, when I think of a hazard, it's basically energy. But we do certain things, whether it's administrative controls or engineering controls or personal protective equipment to separate us from that exposure and prevent those injuries. So this is the hierarchy of controls. So remember I talked about elimination and substitution. Those are better. They're much more effective. I can think of examples of where I've eliminated hazards, and nobody has to worry about anybody being harmed by those hazards ever again. It's the most effective and easiest, once it's done, it's the easiest way to prevent injuries from a hazard is to eliminate it. You can't always eliminate hazards, and that's why we have substitution, that's why we have engineering controls, why we have administrative and work practice controls, and that's why we have personal protective equipment. But I always try to look at elimination first. If I can't do that, then I'll ask, can I substitute it? Then I'll look at engineering controls. I'll just go down from the top because the ones at the top are more effective and long run they're easier. So let's look at our example with the little general in Gent. Could we eliminate the hazard? Well, they probably needed that propane, so I'm not sure we could eliminate the propane tank. Depending on how they were using the propane tank, they could probably substitute it. It sounded like they were kind of substituting it with a tank that was farther away. They were trying to do that. Can we engineer the hazard out? So putting distance between the new tank, where the tank, the old tank was, and the new tank, adding some distance, repairing and replacing propane tank parts. Do we have a system for doing that? What if we could have identified that we had a faulty telltale long before, so that we knew that we had a problem with that tank before we had a situation like that? Can we prevent the propane from entering the store? So those are all engineering solutions that we could put into place to prevent that hazard from getting in and exposing people nearby. What about administration solutions? So obviously we're going to be looking at training for technicians to recognize those hazards, training for emergency workers to get people away from a flammable fuel leak like that, establishing emergency procedures for convenience store workers when there's a problem like that. And they're going to have to provide effective training. So administration is a huge category in this case. And then evaluating and updating emergency procedures and training. So there's a lot of administrative opportunities, and some of them kind of spill over into the engineering controls a little bit, recognizing that propane tank should have been moved sooner, recognizing that the telltale was broken. A lot of administrative controls could have prevented this incident. So the last step is to use your notes from the previous steps to complete your incident analysis form. And you're going to be making recommendations. And you want to make sure that you're making recommendations that are relevant and concise. So make them as clear as possible so that other people who are trying to implement your potential solutions understand what they're saying. Identify who will be responsible for completing the action. So if you've identified something that needs to be done, who's responsible for doing it, and when do we want it done by? And then you're going to report findings to the members of management who have authority to act and make decisions and communicate to employees. And then you want to make sure that these accident reports are being kept on file for record-keeping purposes. Now, on these recommendations that you're making, one thing that is very helpful to management is to get an idea of what kind of priority. that we are going to be seeing here. So one of the ways that you can rank priority of these hazards, of these corrective actions to solve these hazards, is to evaluate how probable is it and how severe is it. Probability is how likely it is to happen. So if it's unlikely to happen, it's going to get a lower priority. If it's imminent, meaning it's going to happen right away, it's going to get a higher priority. But it's also a function of severity. So if it's a minor severity, it may get a lower priority. If it's a very serious severity, it's going to get a higher priority. Okay, and so this is just kind of an interesting, quick tool to try to provide some kind of level of priority for people who are going to be deciding when these things happen. Obviously, imminent danger, so things that are imminently probable and very serious, should be addressed immediately, even if it means shutting down the process. Okay, so this is very helpful when a manager is trying to decide when and what to do to solve a problem or to do a corrective action that you've identified. So these are some keys that I just want to throw out there to help make sure that your process is working. And make sure that your incident analysis process is supported by top management and leadership. That's going to be really key to making sure that these things happen. Also, you want to train supervisors and key employees on incident analysis and make sure that you have a team and analysis tools ready to go when there is an incident or a near miss that you want to analyze. Also, encourage reporting of unsafe conditions, especially near misses. When near misses happen, make sure that employees know that near misses should be reported, especially if they could have been much more serious. Whenever possible in your incident analysis, make sure that you're blaming the systems involved, not the individuals, okay, whenever possible. Because really, the system enabled the incident to happen. That's what we should be analyzing. And there's 4 quadrants. Remember the 4 quadrants to that system: the employee systems, management systems, environment systems, and the equipment systems. We'll be looking at all 3 of those. And then approach the incident analysis process with the mindset of improving processes and reducing the potential for human error. Human error is actually very common, and it's somewhat predictable. So if you can identify a situation where, well, someone might misunderstand this and make this mistake, identify those ahead of time. And then consider employee impact when you're making operational decisions. The decisions that we make when we try to fix and solve hazards, sometimes they have far-reaching impacts that affect other people involved with your processes. So you're going to want to look at what those changes are going to do to your overall system. Take and document appropriate corrective actions and communicate results to everyone. This is a tool that I've provided to you as part of this class. It's not required that you do this, but it is what I call an incident analysis review. Okay, and basically what you're doing as you go through this form is you're asking these 4 questions, and you have key people in your operations that are evaluating these corrective actions, and you're asking these 4 key questions. And you can do this, every 30 days after an incident or every 60 days after an incident. It's just one thing that you can have in place that can kind of do an audit on your investigation, just to make sure that that things aren't falling off the table and that you're staying on top of the solutions that you've recommended. Was the corrective action implemented? Was it? Maybe we're not done yet. Maybe we're still working on it. Okay, if it was, great. If it wasn't, okay, that may be an opportunity for conversation. Was the corrective action effective? Sometimes we think that something will work, and then we find out later it wasn't effective. So back to the drawing board. Maybe we have to come up with some new solutions. And this third one, this is a tough one sometimes too. We went to all this work to solve this problem, and now we created a new problem. But we need to know about them. We need to know if there's any new hazards that have been created. And now's a good time to know before anyone gets hurt. So you may have to address any new hazards. And then the last one is kind of the catch-all. So what still needs to happen? Well, maybe what we said we were going to do initially still needs to happen. Or maybe the corrective action was implemented, it wasn't effective, we need to put it back the other way because it was actually worse. Maybe that needs to happen. This is a tool that your safety committee can use to measure the effectiveness of a accident investigation. If there was an accident investigation done where a safety committee member wasn't available, or if a safety committee member maybe was on there but isn't available in a meeting, you can do this evaluation, make sure that the findings are being followed up on, and just to make sure that the incident analysis was effective in the first place. This is a good tool. This form's a good tool for that. Okay, let's watch this video. So let's go back and look at that. Let's see if I can get it back to the, I want to pause it before we see this. So this gives you a good look at the environment. Now, I remember the first time that I saw this video, I honestly put all of the blame on the employee for hitting that shelving unit and taking that out. But the more I started watching this over and over again, I started realizing that there is so much more context going on with this incident. See if you can come up with something in each quadrant. Environment, look at that environment. How much space does the employee have to drive through in that warehouse? Not much. Environment, what about that? What about how hard did he hit that shelving unit? Not very hard. It should not have catastrophically collapsed based on how hard he struck that. Okay. There's just a lot of things in and around. He's having to weave his way through this warehouse, and he doesn't have a straight shot through here. Doesn't seem like the environment has been put together in a way that's conducive to getting through here with a forklift, with a load. What about equipment? What if we found out that the employee's been complaining about his brakes for the last couple days, and he was trying to hit his brakes, and he ended up striking something. So maybe there's an equipment failure here that we don't know about. I would want to know if he was having some equipment problems when this happened. What if we found out that he was under a lot of production stress to try to get this order out, that there were people, he was trying to take a shortcut to try to get something done quickly. Maybe some management pressure on him to try to get this order out. And so there's a lot of things going on here that well, number one, raise a lot of questions about this incident. But number two, really takes some of the blame off of the employee that was involved. There's a system that's happening here, and it all combined to work to help create this accident. Okay, that's one thing I would just want you to make sure that you understand as you come away from this class. So again, removing blame from your incident analysis process and focusing on how work systems are interrelated is going to build trust in your organization. When you start doing these incident analysis and you start doing them in a way that focuses less on blame and more on fixing the systems and more on learning how to do a better job, people are going to be more willing to speak up when they see problems, less fearful that they'll be blamed. When employees recognize that your motive is to make the team better, they're going to see how to contribute they're going to see how they contribute in a positive way. And all of these techniques that we've talked about today can make your workplace safer, happier, and better. Thank you, and have a great Safety Committee University.